are called the primary trig functions. These three new ones are called the reciprocal trig functions. So the primary are sine, cos, and tan. Reciprocals are these new guys. Just going to review in case nobody ever told you this, is SIN is actually an abbreviation for the function. That's not its full name. It's like calling it Jen when its name is Jennifer. What's its real name? It's signed with an E. Yeah, yeah. And then cos is just an abbreviation. It's like Matt when his name is Matthew. It's cosine. Same thing with tan. That's just an abbreviation. What is tan short for? Tangent. And it's actually interesting because in England they call these sin, cos, and tan. Just a different way to pronounce them. We call them sine, cos, and tan. So we abbreviate to 3 letters, honest to God, just so it fits on a button on the calculator. That's why we decided to abbreviate. So the 3 new ones we're going to look at are CSC, which we do not call KSK, because that just sounds stupid. SEC, which we do not call SEC. And COT, which we do not call COT, because that just doesn't sound good. We call these guys by their full names. This stands for cosecant. Cosecant. SEC stands for, well, if we have cosecant, what do you think we have down here? Secant. So we have sine and cosine, secant and cosecant, tan and, let me repeat that, sine and cosine, secant and cosecant, tan and cotan. Stands for cotangent. Cotangent. And tan we do abbreviate to cotan. So the 6 functions, we call them sine and cosine. Sometimes sine and cos if we're getting really lazy. Secant, cosecant, tan, and cotan. These 2 we just don't abbreviate. I don't know why, we just don't. It's hard to say, so we just don't. What's a reciprocal? Where you flip it, kind of. Kind of. So secant or cosecant, the definition is it's 1 over sine theta. So it's taking sine theta and flipping it upside down. Which in terms of our unit circle is just 1 over which coordinate of the point? Y. And it's also equal to the little tiny formula from cos from grade 10, which was what over what? O over h. And if we flip that, we get h over O. So cosecant is a reciprocal of sine. Secant, reciprocal of cos. Which is the same as 1 over x, which is the same as h over a. Cotan is a reciprocal of tan. And if we go back to our formula that we looked at for the unit circle for tan, as we said tan was sine over cos. Which makes the formula for cotan cos over sine. Tan we said was y over x, which makes the formula for secant x over y. And tan from way back when was O over A, which makes the formula for cotan A over O. Grab your neon card. We're going to start putting down all the formulas for this unit on a card just so it's always right beside you and it's really handy because yes, they're up on the wall, they're over there, cosecant, secant, and cotan. But some people can't read that because it's dark and it's way over there and some people are too lazy to get out the formula sheet. So use this card as a bookmark in your workbook. So when you're working on the homework, tuck it in there so it's always beside you. So we can say sine is 1 over cosecant. I didn't just because it's on orange, but whatever you want. And we can flip those two sides and say cosecant theta is 1 over sine. So the reciprocals work both ways. Sine is 1 over cosecant, or cosecant is 1 over sine. Cos is 1 over secant. Which means secant is 1 over cos. Cotan is I did it backwards. Lefties understand I want to throw that card out and just get a new one. Tan is 1 over cotan. And I'm just going to add the other formula we had for tan, which was sine over cos, since we don't have it written anywhere. And that makes cotan 1 over tan or cos over sine. And so these are the formulas that are on the two blue sheets the furthest from the door. So that's what we've done now is the 3 reciprocal functions and the 2 functions for tan and cos. We'll get to that third sheet a little bit later on in the back of our card when we get there. Questions so far? So all we're doing now is adding 3 more values to all of your unit circle values. So now just by using, don't shake your head, no really we are. Now, not only are you going to know the sine, cos, and tan for all the families, you're also going to know the secant, cosecant, and cotan. So for every value on the unit circle, just by knowing reciprocal functions, you're going to know 6 different trig functions. And there is only 6 trig functions. There's none I'm hiding from you anymore. You've met them all. So first one just wants us to get all 6 functions for 2 pi over 3. So what we did yesterday was just sine, cos, and then tan. We're just adding the three others. What I do first is I think of the coordinates, then I worry about the quadrant. So I just in my head go to the pi on 3 family first. I think of the x-coordinate first, and what has a link to pi on 3? 1/2. And that means the y-coordinate is root 3 over 2. Then I worry about the 2 on top, which is quadrant information. What quadrant is 2 pi on 3? So then I need to use the information I know about Q2 to figure out the sign of the coordinates. What's the sign of the coordinates? Negative and positive. And so this would be thinking. I wouldn't necessarily write it down, but you can. But what the question is asking for is what sine of 2 pi on 3? What's the cos of 2 pi on 3? What's the tan of 2 pi on 3? And then there are 3 reciprocals, the cosecant of 2 pi on 3, the secant of 2 pi on 3, and the cotan of 2 pi on 3. Why? Why do we have to know this? That'll come on Monday. Where do we get the sine value from? How do you remember which is which? alphabetically. So x comes first, cos comes first, sine comes second, y comes second. So that's got to be positive root 3 on 2. What does that make the cos value? Negative 1/2. Tan, you can either memorize those 5 values of tan, or you can just divide y by sine or y by cos, but that's too much work. I don't want to. I want to memorize. What's tan for the pi on 3 family? And because it's in quadrant 2, is it positive or is it negative? It's got to be negative in quadrant 2. So we did these first 3 yesterday and the day before. That's not new. All I'm adding in new is these 3 new ones that you're meeting for today. If this is 3 pi on 2, how do I get cosecant? I just flip it. 2 on root 3. Do we have to fix it? A little more by the word fix. No? Rationalize. So go ahead and rationalize it. No, don't sigh. It's okay. If we rationalize, what do we get? A really quiet 2 root 3 over 3. If cotan is negative 1/2, secant will become, and the negative just tags along. Where did the 1 go? It's underneath, and we know we don't need to see it. And if tan is negative root 3, what does cotan become? Negative 1 on root 3. Rationalize it. What do you notice about the reciprocal of root 3? It's root 3 on 3. And what's the reciprocal of root 3 on 3? Root 3. It'll always work that way. So I just memorize the reciprocal of root 3 is always going to be root 3 on 3. The reciprocal of root 3 on 3 will always be root 3. Again, you can flip it and rationalize. It's just saving you a bit of time. So just going back to the cast rule that we met last year, it's up to you. How does this work with our new trig functions? So what does the A mean in quadrant 1? It means all, and in this case it means all 6. They're all going to be positive. What does the S mean in quadrant 2? Sine, but what's its reciprocal? Cosecant. It's also positive. What does the T mean? Tan, and its reciprocal is cotan, so it's also positive in quadrant 3. Cos stands for, or I told you, C stands for cos, and its reciprocal is secant. So they just go with their partner. What's going to happen is you're going to want to put sine and cosine together, and you're going to want to put cosecant and secant together, and then co and cotan. It doesn't work that way. I remember a C goes with an S, and a C goes with an S. So the 2 C's don't go together, the 2 S's don't go together. Questions so far? Number 2 is doing the same thing for 30 degrees, so list all 6 of them. In my brain, I work better in rads because rad has that link to the first coordinate, so I just think to myself, what is this in rads? What would I need to divide 180 by to get 30? What do I need to divide 180 by to get 30? So this is the pi on 6 family. What are the coordinates of the pi on 6 family? Give me the sine of 30 degrees. Offer of 1/2. Give me the cos of 30 degrees. Give me the tan of 30 degrees. So you can either divide them or you can just memorize what's tan of the pi on 6 family. All we're doing today is just giving now the values of the reciprocal. Sine goes with, oh, thank you. Sine goes with cosecant. If sine is 1/2, cosecant has to be 2. Cos goes with secant. If cos is root 3 on 2, we're going to flip it, make it 2 on root 3, rationalize. Another really quiet 2 root 3 on 3. And tan goes with cotan. Flip it and rationalize or memorize up here. What's the inverse of root 3 on 3? Root 3. Questions so far? Remember way back, like 3 classes ago, when I did that really quick review of grade 11? And we went through everything that you learned, and we look at questions like this. If sine is 1/4, find the exact value of tan. How did we do it? Yes, more specific. Okay, so more specific. We said this is O on H. And then tan we know is O on A. So what were we missing? A, and how did we find A? Pythagorean theorem. And then we had to account for the sign. Remember the cast rule? And then we changed this accordingly. Kind of remember that from like Monday? Exactly the same thing here. It's just now we're throwing in these three new guys. Because we can. Yes. So if sine is 2 on 7 and pi on 2 less than theta less than pi, find the value of cotan. What the heck is all this? So if I just took away the numbers and said less than theta less than, that notation should look familiar from when we've done domain. What does that mean in English, less than something less than? It means between. So all of this is saying that theta has to be between 2 pi and pi. What quadrant is that? Between pi on 2 and pi. So this is just quadrant information. It's just telling you it's Q2. Just a fancy way of saying it. We're going to follow the exact same steps we did last day. It's just now we're going to have a stupid cotan in there. We're still going to label the sides. We know that this is O and this is H. Cotan is what we're looking for. Its partner is tan. What's the little formula for tan? Opposite over adjacent. Flip it means cotan has to be. Which one do I have? Which one do I need? We need adjacent. We have O. So how do I find the adjacent? Okay, so 2 squared plus a squared equals 7 squared. Two squared is? 7 squared is? A squared equals? A equals? Can we simplify the root of 45? 9 times 5. What do we do with the 9? Everybody okay there where that came from? So now we have A is 3 root 5. We had O from the question is 2. The last step, we just need to worry about what quadrant this is in. We just talked about that pi on 2 less than equal to theta less than pi is telling us it's Q2. What do we know about cotan in Q2? Why is it negative? Because its partner is tan, and what is tan in quadrant 2? There's your final answer. That's all the question wants. Find the value of cotan. Find secant. something from 0 to pi, and cotan theta is -3. Okay, same steps as above, so let's take this cotan that we're given and label the sides. So cotan, A over, where does that come from, A over O? Yeah, so it's the flip of tan. What do we know about O? There's nothing on the bottom. It's equal to 1. What are we going to need to find secant? So what is secant's partner? Cos. What's the little formula for cos? A over H. Flip it. What do I have and what do I need? I got A. I need to find H. How do I find H? So H squared is going to equal plus 1 squared yep, little guy over here, -3 squared plus 1 squared, H equals, can I reduce it? Can I simplify it? Can I do anything with it? So secant has to equal root 10 over. Do we know for sure it's negative? Okay, well let's put it for now and then we can talk about the quadrant we're given. Now there's actually 2 pieces of quadrant information in this question. This is one of it, this is the other. So let's talk about them separately. What does this mean from 0 to pi? So if you think in terms of the unit circle, where is 0? On the right. Where is pi? On the left. And this is telling you it can be anywhere between 0 and 2 pi, or 0 and pi. So what quadrants is that? So this is telling us 1 and 2, but this is giving us additional information. This is telling us cotan is negative. Well, what's its partner? Tan. What quadrant is tan negative? So now we're just down to quadrant 2. So because we're in quadrant 2, what do we know about secant? Final answer. How are we doing so far? I'm just eavesdropping. You good? Okay. Now we're going to do exactly what we did yesterday, is work on these exact values from the unit circle, except now we're throwing in cotans and secants and cosecants. Okay, so same kind of questions as yesterday. We're just going to do it from our memory, from visualizing the unit circle. What I do first is I ignore the function. I just look at the 60. I don't want to work in degrees. I want to work in rads because rad has that link to the first coordinate. So first thing I do is I convert this to rads. 60 is the same as what family? And I don't necessarily write this down. I'm just writing it down for you to show you my thought process. Once I have the pi on 3, then I get the coordinates. So I start with the x. What has a link to pi on 3? What does the x coordinate have to be? 1/2, which means the y has to be. If there was a numerator, I would then deal with the quadrant, but there isn't, so we know it's Q1. Now I look at secant, and what I first think is, what is its partner? Secant is related to cos, so I start with the cos value first. Is cos x or is cos y? X, so the cos value has to be. And from there I go back to the secant value. If the cos is 1/2, secant has to be. None of this would I write down because I'm good at them and I can do them in my head. At the beginning, if you need to write yourself notes, write yourself notes. But eventually, by the end of the unit, this is where you'll be. You'll be able to think that through and know the answer is 2. Cotan 120. Again, first off, I don't look at the cotan or whatever because I don't want it to scare me. I just want to look at 120. 120 is what in degrees? So you can either picture where it ends up on the unit circle to get the family, or just use the little formula to convert. 2 pi on 3, I heard people saying. Let's just check it. If I put in 180 for pi, 180 divided by 3. 180 divided by 3. 60, 60 times 2, 120. Now I get, actually I'm not going to go to the coordinates because I want to go to tan, because cotan is related to tan. So tan of the pi on 3 family, root 3. Quadrant, 2. That means tan is. But I don't want tan, I want cotan. So you have now memorized the reciprocal of root 3 is, so this has to be negative root 3 on 3. Again, at the beginning, this takes quite a bit of thought to get through those steps. By the time the end of the unit comes, you'll be able just to look at it, go, yep, pi on 3, root 3, over, flip, done. Cosecant 5 pi on 6. Again, just ignore that function. Just look at the pi on 6 family first. What are the coordinates of the pi on 6 family? Quadrant 2, which means this guy's negative. Now I go to the function. I want cosecant. What's its partner? So I, in my head, get the sine value first. Is 1/2. How do I take that sine value to get the cosecant value? Flip it would give us 2. Questions so far? Again, my chicken scratch kind of off to the side isn't necessarily something I would show. I'm just walking you through my thought process. D is one of these negative angles, stupid negative angles. I ignore the sine, I ignore the negative. All I do first is look at the family and get the values, then I'll worry about the negative. So pi on 6, write down the coordinates. Write down the coordinates. Coordinates are, I heard a really, really quiet root 3 on 2 1/2. Agree? The negative is just quadrant information. What does a negative angle mean? It means we're going backwards. So if you're visual, picture the unit circle. We know pi on 6 is in the first quadrant. So where is negative pi on 6? So all that is giving you is a quadrant 4 reference. What do we know about the two values in quadrant 4? So sine is negative, cos is positive. So what's the sine value of negative pi on 6? Why didn't I flip it? I flipped A, B, and C. What would I flip? What would it have to be for me to flip? Cosecant, not what it asked. It just wants the sine value. Oh, we got a cotan. We got a 3 going on here. We got a bunch of pi's. Ignore the 3, ignore the cotan. Just look at the pi on 4 family first. What are the coordinates of the pi on 4 family? And 7 gives a quadrant reference. What quadrant is 7 on 4? That's Q4. So what do you know about the coordinates in Q4? Positive, negative. Now I'm going to go to the cotan. Cotan is related to tan. So I didn't actually need the coordinates because I've memorized the tan value. What's the tan value? In quadrant 4 it is negative 1. How do I go from the tan value to the cotan value? You flip it. Well, what's negative 1 flipped? It's still negative 1. So I'm just going to keep this 3 for now. And I'm just going to put in that cotan value of 7 pi on 4, which is negative 1. And so what do I do with this 3? Well, it's just a coefficient. What do I do with the coefficient at the end? Just multiply it. What does this have to equal? Negative 3. So a number in front just becomes multiplication. F, oh Lord, look at all this. This is just like two separate questions, so just cover the second one and we'll do the cos of 3 pi on 4. I'm not going to write this time, I'm going to talk you through it. Pi on 4 family, write down the coordinates. Write down the quadrant for 3 pi on 4. Write down the quadrant for 3 pi on 4. Put the signs on your coordinates as necessary. Now write down the cos value of 3 pi on 4. Take a peek at someone sitting around you. If you've got the same number as them, you high-five them. If not, punch them and figure out who's wrong. Woo! What do you have written down? Now I'm going to cover that. We're going to do the second one. Write down the coordinates of the pi on 6 family. Write down the quadrant of 5 pi on 6. Write down the quadrant of 5 pi on 6. Change your coordinates as necessary. Now we actually didn't need all that because it's tan, but I like to have the coordinates so you can see the tan value. So write down the tan value of the pi on 6 family. Now write down the tan value of the 5 pi on 6 family. So again, we don't actually need the coordinates, but I like to see them so that you know you're dividing if you need to. Check with someone, high-five them if you have the same answer. What should we have written down? Why negative? Quadrant 2, 5 pi and 6, and minus 1 on the top. Now this is just two fractions we need to combine, so don't let the roots scare you. They're just fractions. How do we subtract fractions? Common denominator. What's common between 2 and 3? How did I change a 2 into a 6? Times by 3, so what's negative root 2 times 3? Negative 3 root 2. Don't get fancy, don't start changing the radicals, it's just negative 3 root 2. How did I go from 3 to 6? So what's root 3 times times 2, sorry, in this case? What do I do once I have common denominator? Put it over 1 and just smoosh the top together. Can I simplify a root 2 with a root 3? I can multiply them, but can I add or subtract them? Final answer. I just have one more example to go. Okay, so even though it was two questions, we just did them separately, just combined them at the end. G is going to be the same. Okay, think of the pi on 6 family. Write down the tan value of 5 pi on 6. Think of the tan value for the pi on 6 family. Write down the tan value of the 5 pi on 6. What number should we have written down? Because we just did it in the last example. Okay, quadrant 2. I got a cotan plus I got this negative, so I'm just going to draw off to the side. I think in terms of the unit circle, and first thing I say to myself is, where is 5 pi on 6? So forget the negative, where is regular old 5 pi on 6? It's going to be over here somewhere in quadrant 2. So I went a full quadrant and a bit. So if I want to go backwards the same amount, where am I going to end up? I'm going to end up somewhere in quadrant 3. So this is telling you quadrant 3. That's the information it's giving you. So we already know the tan value of pi on 6, so we need to now take the reciprocal. So flip it. Remember we talked about the reciprocal of root 3 on 3 becomes root 3. And in quadrant 3, is that positive or negative? Positive, because tan is positive in quadrant 3. Just going to repeat. I go to positive 5 pi n 6 first to see where I ended up. Quadrant 2, so I went a full quadrant and a bit. So backwards, I've got to go a full quadrant and a bit, and that lands me in quadrant 3. Little imaginary 1 there. What's the common denominator between 3 and 1? So the first fraction is not going to change. It's still negative root 3. The second one, how did I go from 1 to 3? Times by 3. Root 3 times 3. 3 root 3, so not root 9, just 3 root 3. Put it over one denominator. Smush the top together. Negative 1 root 3 plus 3 root 3. 2 root 3. Can I cancel these 3's? Why not? But one's on top of the other. But it looks like I can. Can't cancel a root with a number. That's in grade 11. There's your final answer.